Next, NASA says its Voyager 1 probe, the most distant human-made object in the universe, is sending usable information to Earth again after months of spouting gibberish. The spaceship left the solar system in 2012 and is currently more than 15 billion miles from Earth.
15 billion miles from home, Voyager 1 just smashed into something no one, not NASA, not the top space minds, saw coming. What it's found could flip our entire idea of the solar system's edge on its head. Back in 2020, after decades of cruising through the dark void, our most distant explorer slammed into a wall. But not just any wall. This thing shouldn't even exist. Out of nowhere, its instruments picked up a shocking 8 to 10% spike in magnetic field strength, a reading so wild, NASA scientists were left stunned. It's utterly unexpected, one researcher admitted. An invisible barrier? A magnetic pressure front? Could it be a relic from an ancient supernova? Or something far stranger? Every signal from Voyager takes over 22 hours to crawl back to Earth, yet the story it's telling is shaking decades of astronomy to the core. If our solar system doesn't have a clear edge, then where does it actually end? This 1970s-built craft, powered by a nuclear heart no stronger than a fridge light bulb, is still breaking cosmic rules nearly 50 years after launch. What it's found isn't just a boundary. It's a mysterious, unexplained region that could redefine our place in the galaxy, and no one even saw it coming. Then, early 2024 hit. Engineers finally revived Voyager after a glitch nearly silenced it for good. But when the data started flowing again, mission control froze. It showed that strange magnetic spike hadn't faded. It had kept climbing ever since late 2020. And the shock didn't fade, it kept going for years. Voyager's instruments showed that magnetic field strength holding steady at 8 to 10% above normal, paired with bizarre plasma densities and particle movements no one had ever seen in interstellar space. It's like Voyager hit a wall that shouldn't even exist, one mission scientist admitted, eyes glued to the data. This wasn't just a bump in readings, it was a magnetic pressure front, a phenomenon so far off the books it blew every space physics model apart. Out there, beyond the reach of our solar system, Voyager had found an invisible barrier where magnetic fields squeeze and intensify into a sharp, defiant edge no one saw coming. Some NASA insiders whisper this isn't just some random dense patch of space. It could be the fading ghost of a colossal event. Maybe the leftover shell of an ancient supernova that tore through here millions of years ago. We're seeing magnetic field readings that simply shouldn't exist, said Dr. Adam Sabo, a heliophysics researcher at NASA. His team suspects Voyagers stumbled into a tiny cloud of ancient plasma, supercharged with a magnetic field far stronger than its surroundings. And here's the kicker: that wall is pushing back. The discovery rips open a bigger question. What other hidden structures are lurking in the so-called empty space between stars? Could this be an unseen layer of interstellar space, a magnetic skeleton running through the galaxy itself? Whatever it is, Voyager just became the first to knock on its door. And it answered. What if this isn't just a random patch of space, but a hidden transition zone? A strange boundary that's not fully under our solar system's control, yet not entirely part of interstellar space either. Some scientists now think Voyager's drifted into a denser, more magnetized pocket, a temporary swirl in the cosmic current, like an eddy in a river between stars. These magnetic structures might not be permanent. They could form, twist, and fade over centuries or millennia, reshaping the so-called empty void. The interstellar medium isn't uniform at all, one Voyager researcher said. It's got texture, structure, maybe even its own kind of weather. This might even connect back to a mystery from 2012 to 2015, when Voyager first crossed the heliopause and picked up strange, uneven patterns in cosmic rays. Now the theory is, this magnetic zone could be trapping or funneling those rays, explaining the weird distribution scientists spotted years ago. Picture it, you're sailing across a flat, endless ocean, then suddenly you smash into a coral reef. That's exactly what just happened to Voyager. It's flying through the void, then boom, it hits a structure. Not a planet, not a star, just space acting in ways no one expected. And here's the real twist. We have no idea how massive this thing is, or what it's hiding. If confirmed, this would be the third unexpected boundary Voyager has found. After the cosmic purgatory stagnation zone in 2011, the magnetic highway in 2012, and now this mysterious pressure front in 2024. So the big question is, are all star system edges this wild? Or is ours hiding something truly unique? What else could be hiding just past our cosmic doorstep? And what secrets could it spill about the real nature of interstellar space? One theory is starting to catch serious fire at NASA. And it's huge. They're calling it the ghost of a supernova. Here's the idea. Voyager 1 might have sailed straight into a compressed bubble of magnetized plasma, the fading remains of a massive star's explosive death. When giant stars die, they don't just vanish, one astrophysicist on the mission explained. They scatter their guts across light years, leaving behind tangled shells and filaments of magnetized debris that can last millions of years. Dr. Adam Sabo, a heliophysics researcher at NASA, believes the readings show Voyager slipped into a small, ancient plasma cloud, one carrying a magnetic field far stronger than the surrounding void. This could be an unmapped chunk of the local interstellar cloud, the 30 light-year wide patch of denser gas we're traveling through right now. That cloud itself floats inside an even bigger expanse. The local bubble, thought to be carved out by a chain of supernova blasts over the last 10 to 20 million years. And here's the wild part. Voyager might be brushing against one of those forgotten fragments from long-dead stars. If that's true, this is history. The first time humans have directly sampled one of these invisible interstellar relics. No telescope could ever spot it in this detail. Only Voyager's instruments can feel it. This tiny, 1970s-built spacecraft has basically become our first interstellar field scientist, touching the untouchable. And the implications? Mind-blowing. The galaxy might be crisscrossed with hidden magnetic skeletons, walls, pockets, and twisting channels of plasma sculpted by billions of years of stellar life and death. Space isn't empty at all. It's alive with structure. A shock wave from our own sun? While the supernova ghost theory sounds epic, another possibility points the finger back at our star, not the distant cosmos. A research team led by physicist Leonard Bega believes Voyager may have just run into a delayed echo of solar fury from almost a decade ago. The sun's violent outbursts, coronal mass ejections, and massive solar flares don't just vanish into the void. They keep racing outward, sometimes for years, like invisible tsunamis sweeping through the solar system. Between 2014 and 2017, the sun unleashed several monster storms. Over time, these waves would have merged into what scientists call a pile-up region, a wall of compressed plasma, and Voyager may have slammed right into it between 2020 and 2022. The evidence? Precise timing. Solar events seen near Earth from 2015 to 2017 match exactly when we'd expect their shock waves to reach Voyager's current position, once you factor in their insane outward speed. This theory's being tested by comparing Voyager 1's data with Voyager 2's. Since Voyager 2 exited the heliosphere in 2018 on a completely different route, south of the ecliptic, while Voyager 1 traveled north, it's the perfect control experiment. If Voyager 2 also records the same kind of magnetic spike in the next few years, the solar shockwave explanation would gain serious weight. So the real question is, did Voyager 1 hit something from the outside? Or is it feeling the ripple of something our sun threw into space years ago? Picture it. Someone tosses a rock into a river, and years later, a boat smacks into the waves. Or maybe, the river itself is bending and shifting ahead of us, Either way, if it's solar, it means the sun's reach is far greater than we ever imagined. Powerful enough to reshape interstellar space from billions of miles away. That's what makes this so wild. If it's an internal shockwave, it shows the sun's grip reaches farther than we ever thought. But if it's something external, it means our galactic neighborhood is hiding massive, invisible structures no one ever mapped. Either way, the whole idea of stars and interstellar space being separate? Gone. They're in constant conversation, pushing, pulling, reshaping each other across unimaginable distances. And then came the part that floored scientists, the interstellar hum. As Voyager drifted deeper into this strange magnetic zone, its plasma wave instrument picked up a sound no human had ever heard before. A faint, steady vibration, like space itself was whispering. First detected in 2021, this cosmic hum is a persistent plasma oscillation, a single steady frequency echoing through the interstellar medium. It's very faint, very monotone, in a narrow frequency band, explained Stella Acker, a Cornell astronomer studying the phenomenon. We're literally hearing the persistent hum of interstellar gas. Not a message, not alien chatter, but proof that so-called empty space is alive with motion. For billions of years, these subtle waves have been rippling through the void with no one to hear them. Until now. Scientists are using them to map the density of interstellar space in real time, something impossible from Earth. And here's the kicker. The density readings spiked sharply when Voyager entered the pressure zone, proving it's in a completely different region of space. It's the sound of space breathing, and Voyager's the only microphone out there catching every note. This isn't the silence we thought ruled the galaxy. It's a hidden symphony that's been playing forever. Space isn't just empty, it's a dynamic medium with its own voice. A place where waves, pressure, and maybe even hidden information travel across the darkness between stars. And here's the mind bender. A spacecraft built in the 1970s, so far away its signals take 22 hours to reach us, is now picking up the background tone of the universe. Not silence, not static, a hum. That's not just science. That's straight-up cosmic poetry. What makes this discovery so staggering is its reach. These plasma oscillations aren't rare. They seem to be everywhere Voyager goes. That means this hum might be a fundamental property of interstellar space, a constant soundtrack that's been playing long before humans existed, and will keep playing long after we're gone. Now the haunting question: what's causing it? Could it be carrying faint fingerprints of cosmic events too distant for any telescope to catch? Could there be magnetic tunnels, hidden highways, connecting entire star systems? Just when scientists thought Voyager's surprises were done, its instruments picked up something even stranger. That mysterious magnetic pressure front may not be an isolated wall at all. It could be part of a giant, interconnected network stretching across our corner of the galaxy. This has researchers dusting off one of Voyager's biggest early finds, the magnetic highway discovered in 2012. Back then, it was seen as just a local quirk, a zone where the sun's magnetic field linked directly to the interstellar field, letting particles stream in and out of the heliosphere. But now, the new data hints this might be part of something far bigger. Plasma bridges spanning light years, acting like the galaxy's hidden bloodstream, quietly linking our sun to its neighbors through invisible channels of magnetized plasma. What if the boundaries between star systems aren't walls but gateways? One astrophysicist asks while poring over the Voyager data. If that's true, the sun's reach could stretch far beyond what anyone imagined. And Voyager may have just brushed against one of these cosmic threads. The idea flips our entire view of the galaxy. We've always pictured stars as lonely islands, each wrapped in its own bubble of influence. But what if they're all connected, woven together by magnetic highways, a web instead of a scattered archipelago? Some researchers believe these tunnels might not just carry particles, but also information, the chemical fingerprints of stars, and maybe even the raw ingredients for life itself. This isn't just wild theory. In 2020, radio astronomers found massive magnetized filaments stretching hundreds of light-years near our galaxy's core. Could smaller, hidden versions be threading through our own stellar neighborhood right now? Voyager's latest readings paint a picture of a universe far more interconnected than we ever dreamed. These magnetic pathways could explain how cosmic rays roam the galaxy, how interstellar dust gets everywhere, and maybe even how the seeds of life hop from one star system to another. For now, Voyager drifts along these invisible threads, sending home whispers from a universe that's stranger and more intricate than we ever imagined. And here's where it hits home. These discoveries aren't just deep space curiosities. They matter for us, right here on Earth. The heliosphere, once thought to be a solid wall, might actually be a selective membrane, blocking some cosmic radiation while letting other forces seep through. The border between our solar system and interstellar space isn't a clean line. It's a shifting, porous frontier. And Voyager's telling us it may be far less protective than we hoped. It's not a clean edge out there. It's a layered transition zone with traits we're only starting to decode. And this knowledge isn't just fascinating. It's critical for the future of human spaceflight beyond our solar system's protective bubble. When Voyager crossed into interstellar space, cosmic ray levels doubled compared to inside the heliosphere. These high-energy particles aren't just numbers on a chart. They're lethal radiation hazards for astronauts. The strange magnetic structures Voyager has uncovered could mean pockets of even more intense radiation, or hidden safe corridors for travel. Think of it like charting ocean currents before you sail, one space physicist explained. It can decide whether your journey is safe or deadly. And it's not just about far-off missions. This knowledge has real, immediate value here on Earth. Solar storms and cosmic rays can fry electronics, disrupt communications, and damage satellites. By learning how these forces interact at the edge of the heliosphere, we get a preview of how they might hit Earth during extreme solar events. Most important of all, Voyager is rewriting our map of the Sun's place in the galaxy. The Sun isn't a lonely drifter. It's part of a cosmic ecosystem, tangled in invisible fields and forces that reach far deeper into space than we ever dared imagine. Voyager isn't just exploring for the thrill of discovery. It's showing us how protected, or exposed, Earth really is in this endless ocean of stars. The magnetic zones, the constant hum, the radiation walls. They're not just curiosities, they're warnings. And if we don't pay attention, we're flying blind into the unknown. Voyager's power is fading, expected to go silent around 2030, and every scrap of data it beams home now is pure gold. This aging pioneer, running on 1970s tech, is still rewriting our cosmic playbook in its final years. The big question: what other mysteries will it uncover before its voice is lost to the stars? And what new riddles will it leave for the next generation of explorers to solve? If this story hit you with chills or opened your eyes to how strange and alive our universe really is, hit like and subscribe. It helps more than you think. Launched in 1977, Voyager 1 began as a tour of the outer planets. It gave us jaw-dropping close-ups of Jupiter and Saturn, then kept going, racing toward the edge of the Sun's domain. In 2004, at 94 astronomical units from the Sun, it smashed through the termination shock, where the solar wind slows from supersonic to subsonic speeds. Beyond that was the Helios heath, a turbulent band where solar particles compress and sweep sideways. Then came the shockers. In 2011, Voyager entered what NASA dubbed the stagnation region, cosmic purgatory, where the solar wind stopped cold as if something outside was pressing back. This region wasn't in the textbooks, said Ed Stone, Voyager's project scientist. It was the first of the mission's boundary-bending surprises. And then, August 25, 2012, Voyager hit the helio cliff, a sudden plunge in solar particles and a surge in galactic cosmic rays. That moment marked its entry into interstellar space, and the start of a journey no human probe had ever taken before. And now, nearly half a century after launch, Voyager is still sending back messages from the edge, each one a reminder that the universe is wilder, richer, and far more connected than we ever imagined. But the confusion didn't stop there, because when Voyager crossed into interstellar space, the magnetic field didn't change direction like scientists expected. That twist led to the discovery of yet another strange region, the magnetic highway, where the sun's magnetic field links directly with the galaxies, creating open pathways for particles to move between systems. This was never anticipated, never predicted, Ed Stone admitted. After intense debate, NASA finally confirmed in 2013 that Voyager 1 had crossed the heliopause, the official edge of the sun's bubble, and entered interstellar space. But as we now know, that was just the beginning. Today, Voyager runs on just 4 working instruments. Its nuclear power fades a little more each year. Its signal, traveling at light speed, takes over 22 hours to reach us. By around 2030, the spacecraft will likely go silent. But until then, it's still teaching us about the mysterious, layered frontier it has just entered. In the grand sweep of cosmic time, Voyager's journey has only begun. In about 40,000 years, it will drift within 1.6 light-years of a star called Gliese 445, still carrying the golden record, a time capsule of Earth's sights and sounds, into the endless dark. So what is Voyager sailing into now? A magnetic relic from an ancient supernova? A fossil fingerprint of stellar violence? Or an entirely new kind of space no one ever imagined? The truth is, we don't know yet. But we do know this. The edge of the solar system isn't a border. It's a gateway. Every model we had of interstellar space predicted a dull, featureless void. Instead, Voyager found structure, complexity, and traces of cosmic history carved into magnetic fields and plasma waves. The sun isn't just a light in our sky. It's a force shaping space for billions of miles, colliding with ancient remnants and galactic currents in ways we're only beginning to grasp. One probe, one signal, one unexpected wall in the dark, and a million new questions. If this blew your mind, like, share, comment, and subscribe, because the story of Voyager isn't over yet.